Grade 9 Math. Symmetrical properties of circles. If one part of a figure can be made to coincide with the rest of the figure by folding it about a straight line, AB, the figure is said to be symmetrical about AB, and the straight line AB is called the line of symmetry. Theorem. The line segment joining the center of a circle to the midpoint of a chord is perpendicular to the chord. Prove. Given a circle with center O and a chord PQ whose midpoint is M. We want to prove that angle OMP is a right angle. Construction. Draw the diameter ST through M. Then the circle is symmetrical about the line ST. But PM equals QM. So, ST is the perpendicular bisector of PQ. The line segment drawn from the center of a circle perpendicular to a chord bisects the chord. Prove. Given a circle with center O, and the line segment ON drawn from O perpendicular to the chord AB as shown in the adjacent figure. We want to prove that AN equals NB. Construction. Draw the diameter PQ through N. Then the circle is symmetrical about PQ. But PQ is perpendicular to AB and A and B are on the circle. Therefore, PQ is the perpendicular bisector of AB. Restatement. If TP is a tangent to a circle at P whose center is O, and TQ is another tangent to this circle at Q, then A. TP equals TQ. B. Measure of angle OTP equals measure of OTQ. Prove. 1. OTP and OTQ are right-angled triangles with right angles at P and Q. A radius is perpendicular to a tangent at the point of tangency. 2. Obviously OT equals OT and OP equals OQ. 3. Therefore, triangle OTP equals triangle OTQ. So, TP equals TQ and measure of angle OTP equals measure of angle OTQ, as a central angle and its measure. An inscribed angle and its measure. An arc and its measure. The measure of the central angle equals the measure of its arc. The measure of the inscribed angle equals 1/2 of its intercepted arc. The measure of the inscribed angle equals 1/2 of the measure of its central angle.